Good morning, guys. And let us continue with the next point. I think yesterday we talked about modules and packages. I hope you must have already installed NumPy on your machine. Again, NumPy command is very simple. All we have to say there is sudo if you're on Linux or Mac. Otherwise, simply pip3 install NumPy. So all we have to say here is pip3 install and NumPy. So this is one way to do it. The other way, if you're using pip or if you're facing some problems on pip3, then don't worry, just use pip command as well. So that way also, it'll be easy for you to install it. So pip or pip3, both of them will work. Anyways, I'm assuming that it's already installed on your machine. Now, how do you check it quickly if you really want to check if it is already installed? Simply go back to your command prompt, start a Python, just give me a sec. Let me open it here and I'll show you from there. So a quick test whether it is already installed or not is this. So you can go back here. Sorry, you can use Python 3. That's a Python command prompt we have seen on day 1. And then here you can say import NumPy. If you don't face any error, that simply means the NumPy is already installed properly and you are ready to start using it. So that's the NumPy. And I hope I don't see any problem. That means on my machine, it is already installed. I want to quit here. So better we can say quit and go back to your PyCharm. There is another way you can do it. Open PyCharm preferences, go to PyCharm preferences, and right inside this, you will search for your interpreter. So if you search for interpreter, the project interpreter, whichever is configured on your machine, just below it, it will show you the list of modules installed on your machine. So probably you can go back here and search for NumPy, and yes, NumPy is already there installed on my machine. Another one is like you can click on plus button and you can search for NumPy here and get it installed if it is already not installed on your machine. So if it is giving you a trouble, like it's not working or it's giving you a kind of error while accessing the machine's path or directory, whatever it is, in which case you can go back to your PyCharm and do it quickly like this way. So select the NumPy here and just hit install package. On my machine is already installed. So probably on your machine, you'll be able to do it if it is not already installed. So again, one more time, very quickly, go to PyCharm preferences. If you're on Windows or Linux, you might find that option on edit or file. So wherever you find that option, just go there, search for interpreter. So the interpreter is already configured on your machine for your PyCharm. And whatever the interpreter is selected on your screen, just look below. This is the list of packages you will find. So I think Utpal and Shripati, this is the third time I'm talking about this. Just go back here and search for NumPy and you will see it here. Okay. So probably this is the NumPy, it's already installed, and hopefully this is how you can check it is already installed or not. A quick option right now is another third quick option is right here, create a new file. Anyways, we have to. So let me start with page 1. And right here also, if you say NumPy, that is more than sufficient. So if you face any problem here, probably you can see that NumPy is not installed. If you do not see any problem, that means NumPy properly installed on your machine. Now you are good to go. So now we'll start using NumPy from today. Not from today, we'll use it today. Maybe this is the most important package in Python, at least for those who are going to pursue their career in ML or data science. For them, it's mandatory. For rest of you, yeah, this is also important because there are many other packages which are based on NumPy. One of the famous packages is Pandas, another famous package is SciPy. There are a bunch of others. All of them are based on the NumPy, and that's the reason why NumPy is going to be really important for you. Anyways, so before we start using NumPy, I want to quickly revise the collection. Because NumPy, it's called as a numeric package. Numeric package is used for performing all the numeric calculations, like numeric calculations on array, or maybe you can say on a collection. So before we talk about the NumPy's array, or before we talk about the NumPy's collection, I want to quickly revise what we have seen last time. So if I'm in Python and if I want to go for collections, I hope you can recall there are 4 options for you. Starting with a list, that's the simplest one. Then there is something called as a tuple. Then there is something called as a something like a set. And lastly, there is something called as a dictionary. Set is not that frequently we use, but list, tuple, and dictionary. Those are 3 commonly used collection options available in Python. To use them, I'll create a simple function here quickly to check whatever we have seen last time, whether we can recall them or not. This is important to compare it with NumPy, because NumPy's array is going to keep the similar functionality. So let us see what is an advantage of using NumPy array in a minute. So this is a kind of a numbers collection. I'm creating a numbers collection by putting some values there, 30, 40, and 50, for example. Maybe if I go for countries, maybe I can add a couple of countries, India, USA, UK, that's fine. So basically you can have a numbers collection or you can have a strings collection. Both of them will be kind of easily created by using a collection type list. One of the major advantages of using list is like it is a mutable. Now when it is a mutable, that simply means you can append a new value towards the end of it by saying, for example, 60, or countries dot append, let's say Japan, for example. So this is how we can append it. If you want, you can remove it as well. And this is how we can run a for loop. So maybe I can say for number in numbers. You can simply go back and print the number like this. And hopefully I'm going to do the same thing for the other one, that's country in countries. And there we can say print country. That's it. So this is the way we can solve the problem of getting the data inside a collection and maybe printing it on console. That's it. That's the simplest one you can think of. That's more than sufficient. So maybe if I run this application, if I go for that function one, I see all the values in my collection and I see all the strings in my collection. So working very well. Very quickly, again, this is a mutable collection, and that's the reason why we can add, delete, remove, whatever you say, or insert the values to and from the list collection. Now, when you know that the values are not going to modify or not going to get changed, not going to get updated or deleted or maybe appended, then the best option is to go for a tuple. To go for a tuple, you just need to change that square bracket to parenthesis like this one, or curly bracket. So maybe again I say 10, 20, 30, 40. This is something which we already have seen. It is just a quick recap of what we have seen last time. So that will be easy for me to compare the Python collection with NumPy's collection. So let us come back here and say this is going to be a tuple. Now, when you say tuple, tuple is kind of immutable. And when I say it's immutable, that simply means you cannot modify it. So t1.append not working, t1.insert not there, t1.remove not there, t1.delete, there is nothing. I mean, you cannot delete, update, or do anything with the collection. If the only thing which you can do is once it is created, you can only iterate over it. That's the only thing you can do. Maybe again, I'm going to say the countries. It's better we can just say numbers one more time. Numbers, countries, which is again, I'm going to get those countries back and we'll put them right inside a parenthesis like this. Again, writing, printing code is exactly similar. There is nothing required, or there is no other thing required to just go through that list. So coming back here, I'll get the same output. The only difference between them is like one is mutable, the other one is not mutable or simply immutable. I'm not going to go with the set because set is something which is not required. I'm again not going to go with dictionary as well because dictionary is also not supported in NumPy. So what is supported in NumPy? We'll see that in a moment. But before that, a very quick example, because this is another disadvantage of using collection. So pay attention. I'm going to have one, let's say numbers one, which is going to have, let's say 10, 20, 30, 40, 50. And let's say numbers two. So this is going to be say 60, 70, 80, 90, and 100. Now I want to get the addition of all the numbers. I mean, all the numbers in the sense, I want to get the addition of 10 and 60, 20 and 70, 30 and 80. Means I want to add those two lists together and I want to get the third list out of it. Let me try what happens here. So if I go for numbers 3, which is numbers 1 plus numbers 2, in which case, see what happens here. Let me just go back printing both original and the calculated one. That's numbers 1, numbers 2, and numbers 3. Out of them, numbers 1 and numbers 2 were original, and numbers 3 is what we have just created now. So when I say run, probably instead of giving me the addition, it just appends those two lists together, and probably it is giving me the third list back. My intention was to add all the numbers inside those lists together to get the third list, to get the final list. But instead of going for actual addition, it has gone with the appending one array or one list into another one. So I was thinking about the addition, but unfortunately, it went with something like a concatenation or something like appending the second list on top of one. That's it. So this is something which is a kind of not expected, but still it works. On top of it, if I just go back here and say numbers 4, which is equals to numbers 1 minus numbers 2. So numbers 1 minus numbers 2. Let's see what happens here. So if I go back here and say numbers 4, just show me what happens here. Then you will realize that you cannot use minus. You cannot use a subtract for list. Simple reason behind this is list is not overriding or overloading that operator minus. I hope you recall we already have done that earlier for our classes, like person class or something like a number class. We already have done all the operator overloading concept last time. This means the list here is not overloading that operator minus, and that's the reason why it is not supported. So basically, you cannot go for getting one numbers list maybe subtracted from another numbers list. And to be very honest, when you are talking about the data in a sense, the huge data, as I mentioned earlier as well, today the most important thing which you carry with you is nothing but the data. Data is so valuable, everyone is running after the data. That's the reason why data science is in boom. That's the reason why we are generating petabytes of data every day. That's the reason it is assumed that in next couple of years, not even decades, next couple of years, we are going to start generating zettabytes of data. It's more than that, actually. So basically, if you see here, the data is huge, and that's the reason why we need some programming languages to process it. Python is one of the best programming languages to process the data. When you say data, it's nothing but the collection of values. Think about yourself. Now, when you say you are taking your own data, let's say your number, email, name, address, so on and so forth, what are you getting here? You are getting the collection of type dictionary. When not only you, but if you're getting all the data, all the information about every family member you are having in your family, that simply means you are getting a collection of dictionaries. So ultimately, when you are talking about the data is always considered as a kind of a collection. Most of the times, the collection which we are going to deal with will be numeric. What's the reason behind this? The reason is very simple. Whenever you want to go and pursue your career in ML, you will realize that in ML or in data science, the most important thing here is like you have to have the numeric data with you. Unless you have the numeric data, you will not be able to use that data in few algorithms. So basically, the ML will suggest you something, or ML will do something, or ML will provide the AI functionalities and stuff like that. So probably when you think about that scenario in mind, so probably you will have to get the numeric data, and when you get the numeric data, something like this, for example, then it is but obvious that you want to perform these kind of operations, plus, minus, star, so on and so forth, on collections directly. So it's not like I want to append list 1 onto list 2 or list 2 on list 1. I want to get the addition of them, subtraction of them, and I want to perform a lot of other operations on them. But unfortunately, using a collection framework provided by Python, that's maybe something like a list, tuple, dictionary, and set, it's not possible for me to do it. On top of it, the data which is kind of stored here, it takes a lot of time to get stored, a lot of time to get accessed. The simple reason behind this is, just give me a sec. I think we already have discussed this earlier. So I can go to your directory and will show you what I'm talking about. So if you can understand and if you can recall that diagram, maybe you will understand quickly what does it do behind the scene. Not this one, not even this one. Do I not have the diagram with me? Not even this one. Where is it? Did I? Oh yeah, here it is. So if you pay attention, when we are having, okay, now that's the generic representation, or that's a conceptual representation. Anyways, I think I didn't show you the real implementation. Not a big deal. I'll show you quickly here. See the problem here now. When you are talking about something like the array or something like a list here, this is what is going to happen now. So probably I'll just get a quick array like this. So see what happens, and you will realize why people generally do not use Python's list when they want to process the data. Yes, friend, go ahead and ask your question, whatever question you want to ask. Yes. Okay. So basically, this is what is going to happen now. Again, there will be 5 options. There will be 5 addresses stored here. I mean, I actually don't want to show all the addresses, but just to start with, I'm saying 0x100. 100 is not a valid address. This is just for your understanding. 200. Let's say 300. Imagine that there is a data stored on this memory address. I can't fit all the values there. That's the reason I'm taking a shortcut. But think about this: 100, 200 means 100,000, maybe 20,000, whatever it is. So it's bigger number. Huh? Just to let you know that these are bigger numbers, but just for our understanding, I'm saying that this is where the data is going to get stored. Pay attention, because this is something which we already have discussed earlier. It's so unfortunate that I didn't show you the diagram there, but nevertheless, I'm showing you right away. Okay, so this is what is getting stored behind the scene in your memory. And if it is the case, probably you can understand this is going to be stored in, let's say, 0x15,000 or 0x20,000 or 11,000. What the hell? Here it is. So 0x11,000, whatever it is. So probably this is the memory address of this. And then it is going to point to that particular memory location. See how the values are getting stored. Now there is no secret. Actually, if you can recall, we already have talked about this earlier, and I said that everything in Python is an object, and to create an object, it uses a class. So basically, when you say 10, 20, 30, 40, 50, all of them are integer class objects. And if they are integer class objects, this is an address of that object where the data is stored. So basically, the data is stored not there in the array directly. This is for conceptual thing, that's okay. But to be very precise and to be honest, this is how the data is getting stored inside the memory. So this is one, maybe there are such 5 objects will get created. 1, 2, maybe 3, 4, 5. So that's it. So this is how the 4 and 5. So this is how 5 objects will be created. These are separate objects which will be created in the memory. And those separate objects will have their own addresses stored on these locations. So that 100, 200, 300, 400, whatever I said last time, those are the addresses of these memory locations. This is how the values are getting stored. 0x200, let's say 0x300, and so on and so forth. Let's say 0x400 and 0x500. So these are the memory locations where the data is getting stored. So please remember that whenever you are talking about something like the understanding of how the memory is getting allocated behind the scene in Python's collection, this is what the problem you are going to face when you are using Python's list collection or Python's any collection, because all the collections are more or less getting in a same going to give you a same memory allocation behind the scene. So this is what is going to happen. Of course, inside them you will find the values like 10 somewhere here. This is the integer class object. This is 20 where the values get stored. This is 30 where the value gets stored. To be precise, value also doesn't get stored here, but it's okay for understanding. Again, it's fine. And then 50, something like this, you know. So when you talk about something like this is the memory address. That's the reason why it is pointing to these objects here. These are the addresses of actual memory locations, because this is an object, again, integer class object. And probably you see this is the memory allocation, what is going to happen behind the scene. Again, this is this is an integer class object. So I'll say that this is integer class object. This is an integer class object. All of them are integer class objects. And those objects are getting those values stored in the memory. And that object's address will get stored inside these memory locations. So this is what is going to happen. Again, that's a 0, 1, 2, 3, and 4. So these are the index values. This is something we already have discussed the last time. So this is my 0th index. This is my first, second, third, fourth index. So that's a second index. That's a third index, and so on and so forth. So behind the scene, I mean, it's not that simple to see how the memory is getting allocated. So actually speaking, when you are specifying like I need the numbers of 2, that's 0, 1, 2. What does it do behind the scene? It goes from here to a second location somewhere here. From here, it again jumps on this memory address, and then it gives you the value. The things will become worse when you are having collection of collections. In that case, it has to jump couple of times. When you say numbers of 2, so it first has to accept first has to access the numbers. From here, it has to jump to the second location. From here, this is 300 memory address. So it has to jump back to the memory address, and then it is going to give you the value. So this is a collection representation in Python. So it could be a list, it could be a tuple, it could be whatever it is. This is how the values are getting stored behind the scene. Please understand, all of them are the memory objects. When I say memory objects, these are nothing but the integer class objects for us, because we are storing the data of type integer. If it is a string, then it will be a string class objects, so on and so forth. I hope you can understand here and what exactly happens here. And based on this discussion, I want to continue further with the NumPy. Pranit, your question, is the installation of NumPy only for the current project in PyCharm? Because I created another project, I have to install it again. For now, yes, because you are using the PyCharm. If you are doing it for PyCharm, absolutely. This is going to do it. PyCharm is going to do it for all the projects individually. That's called as a virtual environment. Okay. But if you are doing it from command prompt, it will get installed for every single project you are going to create. That's the reason why I recommend you to go to command prompt and give it a try. But if you are facing any problem there because of any reason, you can come back and do it for every single project from PyCharm. Okay. So Pranit, yes, it is going to create it only for that current project. Okay. From your question, 1,000 of collection data and check the values is used in NumPy. Absolutely. That's the reason why we are looking at it. Priti, in other projects, interpreter can be selected with which contains this package. Yes, you can, but when you are talking about a PyCharm, it by default does it only for the same project. Anyways, so now we see this is a collection of type list. And when I say list, this is how the values get stored in the memory. Now let's see what happens here. As I mentioned, data is very important, and most of the times you are going to deal with the data of type numeric values. If it is not numeric value, you have to you have to convert it into numeric value. How do you do that? We'll see that in ML if required. But right now, just assume that the data you are going to deal with will be numeric data. Now, when you say you are having a numeric data and you are having a ton of data, I want to have a kind of a better facility so that I can process the data very well. I can process the data with best performance and probably least amount of memory. So that's what my target is. And if that is your target, then using a list or tuple or dictionary is not the right solution for you. The better solution is to go for NumPy. Now, why NumPy? One of the best reasons for NumPy is now NumPy is written in C++. In a sense, C and C++, both of them. The reason behind this is because the NumPy developers, NumPy is given by a community. So those developers who have written this application, who have written this library, they wanted to get the best performance out of it with the Python's better or Python's simplest syntax. So they have achieved best from both the worlds. They knew that C and C++ is maybe C or C++ is the best language which will give you the best performance, and Python is the best language because it's the simplest one to learn. So they kind of integrated the C++ code into Python, and they have given this library called as a NumPy, the NumPy which you already have installed now. Now, if you already have installed NumPy, let us see how it can be used and how we can create a collection out of it. So probably when you think about something like a NumPy, please remember NumPy is the one which is going to give you only the collection. And this is used for getting the collection or maybe performing operations on collection. Let's see how to do it. To do it, I'm going to say NumPy, and I don't want to say NumPy every time. That's the reason I'm going to give it an alias. Don't tell me that you haven't seen this before. Yesterday we talked about this earlier. Yesterday we talked about all the different cases of import. At least 4 to 5 cases I showed you yesterday. So I'm going to use that NP so that whatever I want to deal with NumPy, I'm going to start with NP dot something instead of saying NumPy all the time. Okay. Let's start with function 1. So maybe I'm going to start with function 1 here, and I'll say this is going to be a list 1, which is going to store the values 10, 20, 30, 40, 50. That's it. As usual, I'll go for printing the data. Let's say list 1. Sorry, my bad. This is going to be the list 1. And at the same time, I want to print the type of it just to make sure that this is of type list. We know that it's a type of list because we used square bracket, but still, I just want to be confirmed there. Just want to get the confirmation there. So probably I'll start calling that function 1 just to see whether it is a list. Indeed, it is a list. We can see that on console, and here it is a confirmation that it is a list. Fine. So if we know that this is a list, let me try to create an array out of it. An array out of it in a sense, this is the Python's list. So probably I'll just go back here and say this is a Python list. While if I want to go for an NP array, NumPy array, because in NumPy, all the collections are getting stored inside something called as an array. And this array is exactly similar to your C and C++ array. Even though you have no idea about how C and C++ creates an array behind the scene, it's perfectly all right, because I'm going to tell you like how NumPy works behind the scene. That is a secret here, in fact. why people generally use NumPy. So in NumPy, if I want to create an array, this is the NumPy array. You will have to create it like this. A1, that's the array 1, for example, which is equals to NumPy, that's NP dot array, and you can pass all the values here to 40 and 50. Okay, so basically this is how we are creating a NumPy array, np dot array, and here whatever values you want to put in array, you can pass them here. Maybe I'll just go back here and try to say what exactly is stored inside A1 here. So I'll put that A1, and along with that, I also want to put the type of A1. So let us see what is stored inside this. Let me say run, and probably this is list. You see that it is started with square bracket. It has all the values separated by comma. It tells me the type is equals to list. Whereas when you talk about that array, this is how the array is getting printed on console, and this is the type of it. The type of it is something called as NumPy's ND array. Now this ND array stands for n dimension array. This is the most important concept of NumPy. Even though you don't understand anything what I'm going to show you after this, but understanding the basic concept is the most important thing in the NumPy. Why? I'll mention that later. But right now, just try to understand, try to digest something here. Okay. Priti, there is some problem in your installation then, because either you are using it wrong or maybe you're not using it like this one. If you're copy pasting the code, then there must be some problem with your installation. Just go ahead and do it. Go do that installation one more time. Or you haven't imported that properly. Could be one of them. Okay, now let us see what happens behind the scene, and let us see what is exactly getting stored inside the memory when you create an array. Okay. I already have shown you what happens when you create a kind of collection here. So this is a collections memory diagram. Now I'll go back here and we'll show you what happens when you create a NumPy array. Please pay attention. This is going to be literally different. And when I say different, it is way better. I mean, it's different in a better way. Okay, will you please? Okay, so let me just take it outside and then we'll put it again. So right here, I want to use this color black and say I want to store, or I want to create an NP array like this. Please understand this. As I said earlier, NumPy is created in C and C++. It uses the concepts of pointers behind a scene. I'm telling you one more time, Python does not support pointers, but NumPy is written in C and C++, so it uses pointers a lot. Because it uses a pointer, it can directly access the memory by using the memory address. And because of that, the access is way faster compared to the Python. So probably when you talk about this NumPy, I can see that the array is kind of getting created here. Now let us understand how the memory gets allocated here. Okay, before I show any property or before I show the memory diagram here, I'll just show quickly. If I say A1, you see that there is no method called as append, something like insert, something like remove, or something like delete. What do you mean by this? Like tuple, NumPy array is always immutable. Now, why did I say that? I said that it is immutable because that's the reason why NumPy is the fastest one. NumPy already knows, or NumPy's array in ND array, it's called as n dimensional array. ND array knows how many values it has to store. According to this, it automatically allocates the contiguous memory. I mean, it's so unfortunate that I showed you the values so sequentially that you might get a wrong interpretation. It might happen like this as well. Huh? So 0x900, for example, 9,000, 90,000, whatever it is, getting stored here. Because at that time, whatever is memory available, that memory will be used. It's not at all sequential. Please understand the concept here one more time. This is not at all a kind of sequential memory. This can be a kind of this. So probably 300 will be here, 400 will be here, 500 will be here, because it's an object. An object's memory will get automatically allocated whenever it finds the location is free. So this might be the case. 100, 900, whatever it is, wherever it finds the free memory, it goes there, it creates an object and puts that address right inside this index. Okay. But on the contrary, when you talk about the NP array, NPRA knows how many values it has to store. NPRA knows like what exactly the size of every single value it has to store. When I say size, let me just come back here and say print. Maybe I want to say what is the size it wants to store. So probably I can say item size of every value, or item size of every item. Maybe it's equals to directly a1 dot item size. Sorry, i1 dot item size. Item size means how much memory is required to store one single item. That it can print here, and it tells me that, oh, it seems like every item inside that array is going to take 8 bytes. Oh, why 8 bytes? It takes 8 bytes because every value is of type integer. Look at this. I'm going to come back here and I say, what is the data type here? It showed me 8 bytes, but what is the data type here? The data type can be calculated, or data type can be retrieved by saying something called as a D type. I mean, it's something like a data type or D type. When I say D type, it tells me that, oh, it seems like it is an integer 64 bit. 64 bit means there are 8 bytes into it. Oh, that simply means 10, 20, 30, 40, 50. Every value will be using 8 bits to store the entire data. Sorry, not 8 bits, 8 bytes to store the data. And to be honest, it's actually huge. In fact, 2 raised to 64, it goes in so big value that storing 10, 20, 30, 40, 50 is kind of a very simple or very small value in front of it. But still, it is using a kind of integer 64 values. Means in this case, every single value, every single number you are going to store here is going to get a kind of 8 bytes into it. Now, Utpal, I know what you're talking about. It seems like your machine is 32-bit, and that's the reason why it is by default going for integer 32. But listen to me carefully. When you know that the values are getting stored here, which are very small, let's say 10, 20, 30, 40, 50, these values will not require even more than 8 bits to store. 8 bits, meaning you need only 1 byte, and 10, 20, 10 to 50 values are small enough to fit in. Maybe the value fit into the values can be represented by using less than 8 bits. I mean, if I just do the calculation here, 2 raised to 8 is 256. So all the values starting from 0 to 255 can be stored with 8 bits or 1 byte. It seems like the values we are storing here are so small, but still NumPy is giving me 8 bytes here. Oh, can I not optimize my space? Of course, yes, you can. And that can be done by using something like this. I'm going to go back here. We'll create one more. That's going to be my A2. Just want to show you that how you can turn it into an optimized way. In a sense, earlier by default, it went with something like a 8 bytes, but I knew that this is a very small number, or this is a very small number set, and I don't need that much of value. See, every time it's going to go with, let's say, integer 64. I know the values are very small, so can I optimize the storage here? Yes, I can. Just go and say in the second part, in the second parameter, say the D type is equals to np.integer. If you don't want to go for 64, you can go for 32. 32 means, yeah. Now Vishal and Utpal, for both of you, you are getting something like this, 4 and integer 32. Because your machine by default is 32-bit. My machine and most of your machines might be 64-bit. That's the reason it is picking up 64. But you can always optimize it to the nearest value you want to store. So probably if you can say here, like, what is the item size here? It's going to store 4 values. How many values are there? Let's do a calculation here so you can understand what I'm talking about. Number of values, which is equals to a1.size. a1.size will tell you how many values are there. It's like getting the length of your array. So probably you can get, you can see that there are 5 values inside it. Naturally, 10 to 50, that there are 5 values. Means how much total memory is required to store the entire array? So maybe I'll say total memory, which is required, is something like a1 dot item size, memory required to store one value into a1 dot size. There are total 5 numbers. So basically, if you pay attention, this is the calculation of memory. This is the memory requirement for both of them. Do you see that? this array A1, which is storing 10 to 50 values, is taking almost like 40 bytes. But if I know that the values are a little bit smaller, then I can optimize it and I can say that, hey, I don't think these many values, I mean, that much big memory is required to store every value because the value is less than 255. So I'm going to go with in 32 and see I can optimize my memory, which is not at all possible for our list here. Imagine the fact here. I mean, when you look at this, I know your jaw will get dropped. And this is true. Look at the requirement, memory requirement here. To get the memory requirement here, I'm going to import a package called as a sys. Sys is given by Python. It's called a systems package. So this is the sys package. I can come back and say, what is the memory requirement for, let's say, to store a value like 10, 20, 30, 40, 50. In NumPy, I have a direct attribute called as a item size. There is nothing in list. So I'm going to say memory required, or maybe here also I'll say the item size. Item size is equals to, this is the sys dot, maybe the sys dot, what's the name of it? What's the name of that memory? The get size or something. Get size of list of 0. You can go for any position, doesn't matter, because all of them are nothing but numbers. All of them are integers. So I'm saying, give me the size of any one of those values. This will give me the size of every item required to store the memory there. Memory, every value to store inside that collection. Watch what happens. When I say run, jaw dropping, it uses 28 byte to store 10. Only 10 value is getting 28 bytes. Why? Because it's not a simple integer. It is an object of integer class, which has many attributes behind the scene. Guys, are you getting it? Every single time, it is not only a single value. It is having entire object plus reference and all of these things. Like what we have done earlier. Maybe we were creating a person class, storing person's name, person's address, person's age, and blah, 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 blah. All the memory will collectively tell you that how much bytes are required to store one person object. Similarly, this is a class object. This is an integer class object, and every single integer class in Python is taking 28. Maybe this is dependent on your machine. So those who are using 32-bit will get to will use a different number. But if it is 64-bit machine, it's almost like 28. Exactly, absolutely true. If it is the case, this is not a kind of, you know, a simple, I mean, it's not a memory of entire list. It's a memory of single value. How many values are there? Let me just go back here and print that information. Print, let's say, number of values. I can calculate that easily, or I can just get that easily by saying len of list 1, which is going to tell me there are 5 values. So there are 5 values. Every value is going to take, let's say, 28 bytes, jaw dropping again. So total memory required to do this is length of this into sys.get item size of list 1. That's it. So probably if I go back here, it showed me, it's almost like 140 bytes required to store this memory. Unfortunately, I cannot do anything here because the control is in Python's hand. I mean, I can't do anything here. But look at this. I mean, by default, even if it is going for integer 64, it is taking almost like not even half of it. It's less than 1/3 of memory required for storing Python's collection, Python's list. That's the reason why NumPy is preferred. How does it do that? I'll show you that in a minute. But before that, let me try to optimize it even further. So probably I saw that integer 32, I mean 32 bits, or maybe I can say 4 bytes. That is also too much to store this value. Not a big deal. I can still optimize it. I can still go for 16. 16 means 16 bits. 16 bit means it's like, yes, 16 bits means 2 bytes, you know. So A3, 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 everywhere A3, and just try to see how much memory we can allocate in the memory so that we can store this value. See, now it is storing total memory. It's like number of values 5, item size is 2, so maximum it is going to take 10 bits. I'm sorry, 10 bytes. And I can even reduce it further depending on what type of values you are storing, because I know my values are very small. So I can come back here and I can say that these are the values I'm storing, which will take not more than 1 byte. So I can come back here and say, hey, I'm going to go with integer 8. Integer 8 means it's 8 bits or 1 byte. Look, the entire array is going to take 5 bytes to store. Whereas in case of list, the entire array is taking, forget about entire array, one single value is taking 28 bytes. Look at the comparison. In one single object here, or one single value, the memory required to store one single value inside a list is kind of more than sufficient to store entire array in NumPy. You see, when you talk about something like this, you are kind of optimizing your object, optimizing your memory allocation, optimizing your memory requirement, and that's the reason why NumPy is preferred. How 40 came? Where 40 you're talking about, by the way? Which 40 you're talking about? This one? This is 140. How for 140 came? It just because one value is taking 28 bytes. There are 5 values, 28 into 5, 140. Okay. So NPRA needs only single reference, right? Of course, single reference. All of them are looking for a single reference. Even list is also using a single reference. So that's not exactly the deciding criteria. The deciding criteria is memory optimization. I can optimize the memory based on my requirement using NumPy, which is not at all possible when you are going with list in Python. That's the reason why generally NumPy is preferred when you are having a huge collection and you want to perform ton of mathematical operations. Okay. System type x64 based PC, still it's showing 4. Maybe your Python installation is 32-bit. Maybe Utpal, when you downloaded that, you must have downloaded 32-bit version of Python. That's the reason why you are getting this answer. Absolutely. So you must have downloaded that 64-bit. You might have got the 64-bit there. Okay. It's okay. Now you can understand like how we can optimize the memory and how we can use only the required amount of memory for our application. So that's the reason why generally Python collection is not used when you are going for a huge memory calculation. Anyways, let me show you what happens behind the scene very quickly, because that is a kind of a secret here. Okay. To understand this, I'm not going to go with this example. I'm going to go with the second example rather. So look at this example and please try to understand that. When you say this is a function 2, inside this also, I want to create a simple array. That's A1 is equals to, A1 is equals to NP array. Right inside this, I'm going to store 10, 20, 30, 40, 50, and 60. I'm storing 6 values instead of 5. Why? I'll show you that in a minute. But right now, this is the case. You know, so I'm going to do the same thing again. Just want to print all the values and the information about every single aspect of that array very quickly. We already have seen that last time. By default, is going to take, let's say, 64 bits to store or 8 bytes to store. Maybe depending again on your requirement, you can think about it. But I'm going to make sure that it's going to take only a single byte. That's integer 8 is more than sufficient for us to store the values like 1 to this. Sorry, np dot integer 8. And probably, yeah, that simply works well. There are 6 values, which is going to take one single byte to store one value, means there are total 6 bytes required to store the values. Like list can contain the heterogeneous value in array. Can NP? No, you can't. We'll talk about that in a minute, Pranit. So we'll see that. Okay. Before that, let us understand what happens in the memory, because that is a deciding factor. You already have seen this. Now pay attention to something like a ND array. ND array is the heart, is the core of NumPy, and NumPy is the core of data science using Python or machine learning using Python. So pay attention. This is the list of values I'm going to store 10 to 60, and the values are getting stored like this. There will be a reference. No matter which type of collection you are using, a reference is mandatory. So let's say this is going to be 1000, for example. So this is 1000 here, or 10,000 here, whatever it is. Let's say 20,000 here. And in this case, let's say this is an A1, which is of type NP array. To be precise, it's NumPy, something like a ND array. This is the type which is defined behind the scene in NumPy. Now understand what happens here. we are having values like 10 to 50. So those values will get stored like this. So I'll say this, the values are getting stored like this. Will you? Yeah, will you? Yes, please. Okay, so the values are getting stored like this. These are 10, 20, 30, 40, 50. So the values will be stored in this fashion. And because I've controlled the access, or I've controlled the memory requirement of every single value to 1 byte, every single location is going to be 1 byte. So let us understand what do you mean by that 1 byte, and how it is going to affect the memory allocation, and how it is going to affect the total memory requirement here. Let me just increase the spacing and the font size as well, so it will be easy for you to see what is going to happen. Yep, that's it. So let us understand what happens now. Values are getting stored right like this behind the scene, and these values will be stored, it's guaranteed to be stored in a sequence, or maybe contiguous memory allocation is kind of guaranteed here, because this is a C++ or C array. So in like C array, it is going to be contiguous memory location like this. Okay, so let us understand this now. When I say the value is getting created, the array is getting created, maybe the base address is 0x10,000. That's what we have said last time. And this is the 10,000 here then. I mean, that's a base memory here. I can't fit that here. Fine. Not a big deal. Let me just reduce it a little bit. Now I can fit it. See, now this is the memory address of it. Pay attention to the way we are kind of representing it here. So probably this is the memory address. I'm going to use the brown color here just to tell you like this is the memory address. And let us see how the memory is going to get accessed from every single location here. So again, you see that it's kind of going to be pointed to that particular memory, because we are storing the base address of that somewhere here. And this is an integer integer 8 type. Integer 8 type means it's going to take 8 bits to store, or 1 byte to store, whatever you say. So probably I'm just going to copy this one here. It'll be easy for calculation. That's the reason why I'm using it here. And this is how we are kind of storing the, or we are kind of creating the array here, you know. So what is happening behind the scene now? See what happens here. It's like when you create a memory address of, or when you say this is the memory address of 10,000, I think it's better we can just cut one more down. It will be easy for us for understanding purpose, and easy for me to demonstrate this. Okay, so this is 1000 for example. So this is where my array began, you know. So now first value has taken 1 byte to store, meaning the second value will be stored on the second memory location. So it is kind of 1000, then it is kind of 1001. It's guaranteed. It's 1002. It is 1003, 1004, 1005. So that is how the values are getting stored sequentially, contiguously, one after another. So this is how the values are getting stored. I hope you can understand. When I say something like integer 8 means it's 8 bytes. I'm sorry, 8 bits. And when I say 8 bits, that means it is a 1 byte. So every next value will get stored after 1 byte. After 1 byte memory location like this. So this is where it is going to start with 1000, 1001, 1002, 1003, 1004, 1005, so on and so forth. It will continue storing the values like this sequentially, contiguously. Now you might ask this question like, what's a big deal here? Because last time also the values are getting stored, this time also the values are getting stored. But see the magic and see the reason why people use NumPy. Let's try to get the value at, let's say, second memory location. When you are using list, what happens? First, you have to go from here to here, second memory location. And from here, you have to again jump. And inside this, you are going to get your value. But when you are talking about this array, you can directly see the value is stored on that memory location. And when I say the value is getting stored at that memory location, see, when I say this is 0, 1, these are the memory, you can say address, memory index positions you are going to use behind the scene to access all of these values. So when you talk about these index values or index positions, you can easily see that the way we are storing the values are contiguous. So if I want to access any of the value, all we need to know is like the base address and which position you want to go for. So probably if I want to go to, let's say this address. Okay, so if I want to go to the second value, I know the base value is somewhere here. I just want to add 2 bytes into it and I'll get the value right here. That is the value 30 I'm looking for. Not like this, first here to here, then here to here, and then you will find the actual value there. Not like that. So from here, you can directly go to this memory location. You know the base memory address here. The base memory is 0x10, 0x1000. If you want to go to the second location, you just add 2 into it. 2 into item size. What is an item size here? The item size right now is something like integer 8, means it's 1 byte. So maybe I'll just go back here and say currently the item size is equals to 1 byte. And probably it's 1 byte, and that's a reason why it is reasonable to say that every time you just have to add 1 byte into the position you want to add there, position you want to go there. If I want to go to the 4th position, this is the base memory. I know the item size is 1 byte. I want to go to the 4th memory location. So add 4 into it and you will get the memory location where the 50 value is stored. Now you can go there and you can grab the value. Guys, are you getting it? Yes. Adesh, it's called as a scale factor. Scale factor is nothing but here is 1 byte. Why it is 1 byte? It is 1 byte because we said that the data type is nothing but int 8. If it is a kind of int 16, then it would have stored 2 bytes. It's like 0x1000, 0x1002, 0x1004, 0x1006, 0x1008, and so on and so forth. So that is generally called as a scale factor. Absolutely right. So when you are talking about an array in NumPy, this is how the memory is getting laid out. And because of that, it is possible for NumPy to directly jump on that location to retrieve the value. Not like this, double jumping or triple jumping if you are having collection of collections. So that's the reason why we generally go for a something like something like a NumPy array. Okay, maybe Vipin, you are saying, can we say that the previous list, it was carrying the 3 references and 1 data value, turning it to 28? Exactly, you can say so. So that's 1, 2, 3. 1, 2, and 3. That's the reason why it is kind of taking 28 bytes. Who cares? In fact, it is the way it is doing it behind the scene. When it keeps many different things out there, but behind the scene, what needs to be understood here is like whenever you are storing the data is not stored as an integer value. It is getting stored as an integer object. And whenever you talk about the object, definitely the memory requirement will be larger than the memory requirement for storing a single value like 10, at least in this case. I know 10 value can be stored in less than maybe 3 bytes. So even 3 bytes are more than sufficient to store, not 3 bytes, sorry, 4 bytes. 4 bytes are more than sufficient to store 10. 4 bytes means 1010, 10's binary representation is 1010. Means we need only 4 bits to store it. Not even 4 bytes, sorry, 4 bits to store it. And when I say 4 bits is more than sufficient, in case of Python, it takes 28 bits to store the value. That's the reason why it is so unfortunate that we don't use, or so unfortunate that it is taking so much of memory and we can't control it. That's the major problem. Here, we can control it. Depending on our requirement, we can control it. So this is the way the values are getting stored behind the scene. Guys, do you understand what I'm talking about? Any questions so far? Okay, there is no answer, there is no question. That simply means you are getting it better. Okay, fine. Okay, now when you talk about this total memory, there is something called as, I guess there is something called as n bytes as well, directly given. I mean, you go for multiplying item size or a size, or let the Python do, let the NumPy do it. Both of them will be exactly similar. So you go for this way or you go for this way. Both of them are absolutely okay. Okay. Now there is one more thing that I want to talk about. Very, very, very important. When you talk about this array, you saw that this array is one-dimensional array. Okay, this list is one-dimensional list. This array is one-dimensional array. If this is one-dimensional array, I want to prove the fact that this is a one-dimensional array. There is no way I can prove here, at least in case of list, but there is a way you can prove in case of array, and that is going to be very important again. So check this here. Number of dimensions. How many dimensions are there? I don't know. Let me just go here and say ndim. Ndim stands for n dimensions. How many dimensions are there? There's only one dimension. But let me run this code and prove the fact that this is a one-dimensional array. Now, when you talk about ND array comes with something called as a shape property. Shape will tell me how does that array looks like. So this is called as a shape. You can go back here and say print the shape, and the shape will tell you how does it look like. Now, because the name is ND array, n dimensional array, the same array can store n dimensions, means multiple dimensions. And when I say it stores multiple dimensions, number of dimensions will be represented as number of values inside the shape. Right now, there is only one dimension that you can see here, and that's the reason it tells me that there are 6 values in the first dimension. If I create two-dimensional array, probably you will see the dimensions will change, and so the shape will also change. For example, let me just go back here and say def, that's function 3, and I want to create a new array here. I'll do one thing. I'll just copy every single thing one more time and simply change this to something like 10, 20, 30, and 40, 50, 60. That's how I want to do the job. Very, very, very simple. You know what? Everything will be exactly similar, and probably if I try to call this function, sorry, I forgot to call that. So if I call this function, if I call this function here, you will see that everything will be same except the number of dimension is changed. Earlier there was only one dimension, and now this is two-dimensional. The two-dimensional means you can see that right here. If you can observe this, this is how we are storing the collection. This is how we are having 2 rows and 3 columns within it. 2 rows, because you see that it's 1 row and this is 2. I mean, there are 2 rows here, and these 2 rows, row 0, row 1, and these 2 rows are having exact same number of columns, and that is 3. Exactly. So there are 2 dimensions in it. First dimension is having 2, second dimension is having 3 values inside it. So there are 2 rows and 3 columns. I hope you are getting it. What is the question, Adesh? It's nothing but the advanced version of C language. No, it's not advanced version. It is the C language itself. It's not advanced version because it is written in C. So it has to be exactly C code. Okay. Okay. So probably if you can see here, the values are getting stored behind the scene into 2-dimensional. That's what we understand it from the way the memory, or the way the values are getting stored, or the way the values are getting represented here. So it says there are 2 dimensions, and it says there are maybe 2 values in the first dimension and 3 values in the second dimension. But you know what? Let's go back here and let's inspect now what happens behind the scene if I want to create an array like this. Please understand that this is crucial. And when I say crucial, it's really crucial. See what happens here. It's going to take a lot of time for me to do it. It's better we can just do it quickly by using something like this. One single row or one single line. It will be easy. And it will be easy. Okay. So this is how I want to store. I want to put the values there. So yeah, that's okay. And let us see what happens here. By the way, why I'm showing you these 2 examples, because I want you to understand the difference between 1 dimension and 2-dimensional array in NumPy, not in Python's list. In Python list, we already have seen it. What happens behind the scene? This is, I'm sorry, this is a 1-dimensional array, and this is 2-dimensional array. So this goes here. This is the 1-dimensional array, and this goes here. That's a 2-dimensional array. When I say 2-dimensional array, that means there are 2 dimensions in it. That's the row and that's the column, you know. So let us see what happens behind the scene, how the memory is getting allocated for this A1 here. What do you think? How the memory will get allocated? Of course, there are 2 rows and 3 columns, right? So how the memory will get allocated? You know what? You don't have to think twice. Exactly as it is. Exactly as it is. You know, that's the secret of using Python. That's a reason why people use Python a lot. Not Python, NumPy in Python a lot. So let me just go back here. I think we are using two here, right? So probably, wait a second. I think it's better for me to use one memory location, or to use integer 8 instead of using integer 16 here. It'll be easy. Otherwise, I'll have to again draw the entire diagram. It's okay. Just to say integer 8 here, you know. So when you create this memory location, when you say that this is the integer 8, again, it's going to be the item size, which is equals to 1 byte. On top of it, you are going to have some more information. The shape of this is something, pay attention, the shape of this is equals to 2 by 3, and this ndim, ndim, which is equals to 2. So precisely in this case, this is the information that is important for you to understand how the values will be read. Values will be stored in this way, there is no change, but the values will be read in a little bit different fashion. See how many values are there? There are 6. There is nothing here. And there is only one dimension here. I showed you this information earlier as well. You see, if I compare this with the next values, this is my function 2. If I just put that function 2 here and turn it on. So you see that in function 2, we have created an array of 1 dimension. And that's the reason I see ndim is equals to 1 and shape is equals to 6 comma. Second array looks like this, which is a kind of a 2 by 3, which means there are 2 dimensions. First dimension is having 2 values because there are 2 rows, and second dimension, that is the number of columns, there are 3 in each row. That's the reason why we are getting the dimension as 2 and shape as 2 by 3. So simple enough, 2 by 3. So that's how the values are getting read from the memory. But while storing them, this uses the same philosophy. This is called as a flat structure. When I say flat structure, it doesn't matter whether it's a 1-dimensional or 2-dimensional. Behind the scene, the values will get memory address contiguously like this, and on top of it, the values will get stored in a flat list like this. Now you might not agree with it. You might say, what's wrong with you? Because in this case, how the values will get accessed if you are having, let's say, 2 dimensions. Because when you say 2 dimensions, for us, for a human being, when I want to understand the situation, I want to understand it from two values or two maybe dimensions. One is the row and second one is the column. But you know what? Behind the scene, it is going to store like this. So there'll be value like 16. That's what we said last time. Somewhere here. And the value 60 will get stored right inside that location. So this is value 60 here. This is value 60 here. And then the description matches. Now, I forgot to say 60 here. No one really asked me to update it, but it's okay. Nevertheless, you might not have seen it. Neither am I, in fact. So I forgot to mention that. It's okay. So 0x 1005. That's a memory location I'm talking about here. And you know that that's the 5th memory location there. It's okay. So now you see the values are getting stored in a flat memory structure. This is also storing the values in a flat memory structure like this. But how does it read the value? That's the important point. So when you read the values like this, how many dimensions are there? There is only 1 dimension. That's the reason it reads all the values in this fashion. There are 6 values in 1 dimension. So it goes contiguously, reads the memory, and it gives you back. Now let us understand what does it do behind the scene when it is having ndim more than 1. In this case, there are 2 dimensions. That's what we mentioned. When I say 2 dimensions, in first dimension, there are 2 rows, and in third dimension, there are 3 values. So what does it do? It divides this it divides the number of values into number of rows first. There are 2 rows, or this is the first dimension, you can say. So this is how it does the job behind the scene. It says starting from this, there are 2 rows and 3 columns. Means we have to split that into 2. When I say we want to split that 2, in a sense, the 6 values will be splitted into exactly equal part of 2, which is going to have 3 columns within it. That's my first one, and that's my second one. You know, so the row will start from here to here. Second row will start from here to here. And then this is the 0th object. This is the 0th column inside the first row. This is the first column inside the first row. This is the second column inside the first row. This is the 0th column inside the second row. First column inside the second row. Third column inside the second row. It does that calculation on its own. That's how it does the job. In a sense, it first needs to identify where it starts. how many rows are there, how many columns are there, and based on that it gives you the memory. It reads the memory like this. Exactly. Now the scale will be a sum of 2. Exactly. Right now I'm using 8, so that will be scale equals to 1. But if you are using integer 16, the scale will be of 2. I mean, in a sense, when you are having a flat structure like this, when you are having a structure like this, then it is going to read the memory location as 1 2 3 first row, next to 1 2 3 as a second row. If you are having one more, it will again get stored in a flat structure, and this is how it is going to store. It's going to read the value. Wait a second. I mean, I don't want to waste your and my time, but I know I have already drawn a little bit detailed diagram last time. Just give me a second. Let me see if I can find it. If I can, probably it will be better for you to get the things there. Okay, not here. Do I have that somewhere? I know I already have drawn this diagram earlier in detail. So somewhere, this is a single memory location, not for you. This is the one, second row, first row, third row, but I know I have drawn it somewhere. Leave it. I'm not able to find it right now. Maybe if I find it, I'll share it with you. So, okay, must be here in the full time. Just give me a sec, because I showed these guys a demo of it. So probably these guys must be having that diagram somewhere. Not for you. This is again the same thing I'm talking about, but better I had drawn this diagram. I don't know. Where did I put it? I draw too many diagrams and I forget them. Anyways, if I find the time, I'll do it later, and I will show you, will share it with you later. Okay, so probably when you talk about something like this, you see that that's my first row and that's my second row. So that's what I said. That's my row 0 and that's my row 1. So it starts here and row 1 starts here. So that's how it does the job. So row 0 value 0, row 0 value 1, row 0 value 2. Again, row 1 value 0, row 1 value 2, value 1, and row 1 value 2. That's how it goes. Okay. Preeti, your question, but sir, if any delete or insert operation done on the array now, how will it result here? Very good question, Preeti. But you missed one thing. Did I mention last time? Yes, I did actually. NumPy array is actually immutable. That's the secret behind it. You know what? Exactly. Because of the mutability, Python list uses so much of memory that it has to do that adjustment. So it has to have some buffer in between, so that if it has to do any kind of adjustment, it can do it at runtime easily. That's the reason it takes a lot of memory there. But on the other hand, NumPy array is immutable. That's the reason why it doesn't require any kind of adjustments there. That's the reason why it is faster. Absolutely right. Rohit, yes, that's why it is the case. Absolutely true. Okay, now enough about this. Probably you now got the point here. So the main point here is, yes, NumPy is taking less memory, not less, way lesser memory than a Python's collection. Okay. Now let's continue further. Let's create a third page here and see how we can deal with a couple of different operations on NumPy's array. So guys, try to understand this now. Last time I showed an example of the Python's collection, Python's list. Now let us do the similar operation on the NumPy's array. Again, same thing, import NumPy as MP. Again, I'm going to start with the function 1. Sorry, function 1. Right inside this, I'll create two arrays. Let's say A1 is equals to, np dot array. Let's add array 1, 2, 3, 4, 5. Very simple. And again, A2, maybe I can just copy and paste it here and say this is A2, which is having the similar values. Of course, both of them are different objects, or both of them are different arrays storing the same values. I want to go here and see what happens if I want to perform an operation here. You know what? So probably if I ask you, like, instead of going to consider this as a function 1, let's consider this as a function 2 and say this is function 1. And if I ask you, like, if I have a kind of, let's say, a list, L1 is equals to this, not an array, but L1 is equals to list. Can you tell me, how do I add a 10 into this value, 10 to every single value here? If I want to say, yes, 0 plus 1, not append, I'm saying, 1 plus 10, 2 plus 10, 3 plus 10, 4 plus 10, 5 plus 10. In a sense, Exactly. I want to add a 10 value in every single position. What do you do? Exactly. Someone is saying loop, someone is saying map, someone might say something called as, remember, something called as a list comprehension, so on and so forth, right? Which means we'll have to iterate over it and then we'll have to add a 10. The simplest option I'm going to go with here and say print. I'll go for a list comprehension and I'll say that num plus 10. It's not going to store anything, but at least it's going to give me a new collection where for num in L1. That's it. So this is how it is going to do that adding operation to every single value here, you know, as simple as that. 11, 10, 11, 12, 13, 14, 15, which means I have to iterate over the collection, which means I'll have to either do it by using list comprehension, map, or for loop, depending again, whichever you like. Now you are in NumPy. In NumPy, you don't have to do it because in NumPy, let's talk about that A2 in a minute. In NumPy, whenever you are having an array, you can perform these operations easily directly on an array. So maybe in this example, I want to show you what happens when you say A1 plus 10. Surprising, A1 plus 10 here will not add a 10 into it. We'll just do it one more time with list and then we'll come back here. See the difference. If I want to do it with L1 plus 10, see what does it do? It does not give me a kind of, you know, addition operation based on L1 plus integer. You cannot add a list and 10 because it's not possible. That's the reason why we were running a for loop, or we were using list comprehension, or we were using map function to do the job. But now you are in NumPy. See, I can directly add 10 into A1 and it does something similar to what we were doing earlier by using list comprehension. So tomorrow, if you are storing a list of salaries or a list of employee salaries, and if you want to add a kind of a bonus, you don't have to go and run a for loop over them. Just add 10 or add whatever bonus you want to add into directly that array, and it will get added to every single value stored inside that array. If you can see this, what has happened, it has added 10 into every single value. 10 plus 1, 10 plus 2, 10 plus 3, 10 plus 4, 10 plus 5. When you are in NumPy, it said that in NumPy, all these operators like plus, minus, maybe star, maybe modulus, all of these operators are called as broadcast operators. What do you mean by broadcast operator? Broadcast operator means the operation will be performed on every single value inside that array. So even if it is a star, or even if it is a slash, or even if it is a plus or minus, all these operations will be performed on every single value inside it. Let's say minus, let's say star, and let's say divide, you know. So if you are running this application, you see that it is getting added, maybe getting subtracted, getting multiplied by, and getting divided by every single value there. That's the reason why it is known as a broadcast operator. Way different than what we have seen in list. It's so handy that if you are storing some values and if you want to perform the operations on top of it, you can easily do that with those operators. Guess what? I can do the broadcast operators directly by using comparison operators as well. So this is broadcast operators. Which operators are they? These are mathematical operators. So I'll say mathematical operators. Same thing, broadcast. I'm going to go with the comparison operator. Broadcast comparison operator. It's so handy. I'll show you a couple of different things which will make the things possible in NumPy, which is not at all possible in list. So let's see. What do you mean by this? I'm going to come back here and say, hey, is every value inside A1 is greater than, let's say, 5? Do I have 5? 1 to 5 or 10 to 50? Okay, 1 to 5. So I'll check it with 2. Is it greater than or equals to 2? Is it less than 2? Is it less than or equals to 2? And is it equals to 2 and it is not equals to 2? So basically all operations will be performed directly on every single value when you use this broadcast operator. Watch what happens. So it tells me that false, false, true, true, true. What do you mean by that? It is checking if every value is greater than 2. Is 1 is greater than 2? No. Is 2 greater than 2? No. Is 3 greater than 2? Yes. 4? Yes. 5? Yes. Look at greater than or equals to. Is 1 greater than or equals to 2? No. Is 2 greater than or equals to 2? Yes. True, true, true. Similarly, it is doing all of these broadcast operations behind the scene. It is so handy. Believe me, later when you go to ML, whenever you go to ML, there you will understand when you want to perform many operations, you just have to go back and use this as a broadcast operator and it will do that job easily. Yes, Shreya, it was my mistake. I should have said that less than equals to, but nevertheless, you know the operations now. You see exactly what you are guessing here, exactly what you are kind of using here. Maybe you will get the result accordingly. Yes, so you get fixed. I mean, I fixed that problem. So all these operations will be performed on every single member of that array. This is the reason why it is said that these operators, like mathematical operators as well as the broadcast operators, these will be kind of working in on these arrays like a broadcasting way. Broadcast simply means they will be working directly on every single member of that array. Guys, are you getting this point? Any questions so far? Are you really getting it? Can you print number 2? Yes, yes, wait, Utpal, wait, that's what we are going to now. Exactly, that's what we are heading to. But just wait for a minute. So you will understand what does it do and how does it solve your problem. Okay, so this is the example, this is the function in which we were talking about individual operators like mathematical operators and something like comparison operators. Now let's deal with two arrays directly, which was not possible earlier in case of list. Now we'll try to do it in case of this NumPy array. See, A1 plus A2. I showed you earlier as well when you were doing that L1 plus L2 last time, list 1 and list 2. At that time, instead of getting the addition of every member, it was giving me a kind of, you know that, it's kind of a appending behavior. This is not the case when you are performing all these operators. Again, all these are mathematical broadcast operators. I'll simply say the broadcast operators. You know what do you mean by that now? So you may say A1 plus A2, A1 minus A2, A1 star A2, A1 divided by A2, A1 modulus A2, and so on and so forth. All these operators will be performed on the arrays directly. And when I say arrays directly, that simply means all of them will be performed in a broadcast way. You see, whenever you are talking about addition, it's 1 plus 1, 2, 2 plus 2, 4, 3 plus 3, 6, so on and so forth. 1 minus 1, 0, 2 minus 2, 0, 3 minus 3, 0, 4 minus 4, 0, 5 minus 5, 0. Again, 1, what is that? 1 star 1, 2 stars 2, 3 stars, so on and so forth. Again, A1 divided by 2 means 1 divided by 1. All of these numbers getting divided to themselves will give you the answer like 1, and so on and so forth. So when you are performing these operators on an array and a number like this, or maybe when you are performing these operations or maybe using these operators on two different arrays, every time you have seen they are giving you a kind of broadcast behavior. Broadcast means the operation will be performed on every single value inside an array. That's completely different than a Python's list. Okay. Can we print answer along with the values? We are actually, okay, you want to print the answer along with the values? Not a big deal, sir. All we have to do here is this. Just go back and say something like this, isn't it? I mean, it's so simple, like you can go with the A1, A2, or if you want to print the A1 plus A2, you do the rest of the things. I'll just show you only one. So you will understand this plus this is equals to this. Is that okay, Anusha? I think this is what you are looking for. You may say A1, A2, or you may directly print the values like this. Okay. So anyways, I've done that. So it's very simple for me to do it again. It's just copy pasting. So probably I'll do it 4 more times. As easy as that. All I'm going to say here is 1, 2, 3. I can't do it. Sorry, my bad. We'll have to do it 1, 2, 3, 4, and 5. That's it. This is how we can do it. Again, just use those right operators here. Star. This is slash, and this is percentage. That's modulus. So I think this is what you're looking for, Anusha. I think this is the answer to your question, you know. So this is how we can perform all these operations, sir. Very, very, very simple. Adesh, how to concatenate in this case? No, you can't. You can't concatenate. You know why? Well, because this is immutable. You can't. Okay. So probably for concatenation, you will have to go for maybe running a for loop or something, your own logic. But otherwise, by default, is going to do the mathematical operations. Milin, Now you are getting the feel of Python. Yes, that's what I said yesterday. Starting from today, we are in the advanced mode. You already have seen Python as a language. You already have seen the syntax, but you never have seen these functionalities which are used in the real environment, in the real programming. In the real programming, these packages are used every now and then. That's the reason why we are looking at them, a kind of introduction to those packages. Vipin, your question, can we overload an operator to concatenate type? You can't, because NumPy is not in your hands. You can do it for your classes, but not for NPPy. You might have seen that when you want to override it, for overridden, you'll have to write a class. Unfortunately, NumPy or ND array is not a class. ND array is given by NumPy. That's the way it is kind of representing it. Okay. And this is not written by you. So you can't override that overridden operator for you. I mean, if you are writing your own class, then it will be possible for you to do it, but you can't overload an operator for other classes. So not possible. Prashant, how will it work if there are two asymmetric arrays? One array is of length 3 and the other one is of type 5. Absolutely. I knew someone will ask that question. Now, in this case, when I say it's going to perform an operation like A1 plus A2, means every single member of 1 will get added into every single member of with the second array. It will do that position wise. So precisely 1 plus 1, 2 plus 2, 3 plus 3, 4 plus 4, and 5 plus 5. I understand that. It's very simple to do it. But what if I have an array which is not matching with the other values or other array size? What will happen in that case? I can add 1 to 5, but what about 6? So what will get added to 6? Nothing. Nothing means you can't do it. You see, when you want to perform these operations, it is mandatory that you should have both of them matching their shapes. So Prashant, that is an answer to your question. So you cannot perform this operation, and this is logical ones. Don't you think so? So if you want to add two arrays by position, you have to have the same size in both the arrays. So it's not possible for you to do it. Okay, so I wanted you to ask that question. That's the reason I didn't show you that, but thanks for asking the question. Otherwise, I had to ask myself and answer that question again. So probably thanks for asking that question. And this is the answer. You cannot add these arrays if their size is not matching. Not size, sorry, shape is not matching. So their shape must match. Then and only then it is possible for you to perform these operations on those arrays. Okay. Suyog, what if A2 contains one extra item? Sorry, Suyog, I think you got the answer. I already have shown you here. Nikhil, your question, line number 42 is star. Line number 42 is a star. Sorry, my bad. And I forgot to mention that here. This is the next one here. Rather, all of them I mentioned earlier. Maybe mathematical, maybe comparison. There is a logical operators as well. That is giving me a kind of better option. That's a logical and logical or. So logical and something like this, and logical or something like this. Same thing is true for here as well. I can go for logical and logical or, you know. So probably I'll just go back here and say logical and. So probably it doesn't make any sense to go with logical and with numbers. So I'll create one more. Okay, so this is a kind of A3, which is equals to say true, true, false, false. Then A4 is equals to, let's say true, false, true, false. Say true, false, true, false. And then let's perform these operations, you know. So this is where I want to print A3 and A4, which is equals to A3 and A4. So this is an operation here, logical and operation and logical or operation. So here and or will not be used. Here ampersand and something like and will be used. I'm sorry, man. Yes, it's my bad. It's not a list. It should be NP array. You cannot perform these operations there with the list. My bad. Now you see that true, true, false, false, and true, false, true, false. You see, true and true is true. True and false is false. False and true is false, and false is again false. So that's the reason why you're getting the answer as true, false, false, false. This is a simple AND operation. It's nothing different than that. And one more time, it's true, true, false, false, and true, false, true, false. In this case, we are using OR. So true or true, true, true or false, true, false or true, true, false and false, false, false or false is false. So you will get exactly opposite of this answer. So it's true, 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 false, something like this. Okay, who's that? Okay, I think Nikhil, thanks for letting me know that. That gave me a kind of another option to show you behavior here in case of array, numpy array. Okay, so this is called as a logical operator and logical operator or. Guys, are you there? People are dropping off in between, I know, but it's okay. What's the difference between and or? I'll show you this here. What's the difference between these two? So let me go back here and use another operation. Let's say ampersand, ampersand, and or. Ampersand, ampersand, and or. Now watch what happens. When I do it here, the first thing, you can't go for double and then double or. So first thing is, it's not supported. It's not supported in the sense when you are using, when you are in Python, you cannot use double and then double or, because it's like logical ending and bitwise ending. Absolutely. I mean, I said that here logical ending, but behind this, it is a bitwise ending. True. That's correct. This is logical ending. I mean, here, though it is a bitwise, we are using it as a logical ending because true and false, all of them are getting sorted or getting evaluated as logical already. Okay. So that is not possible. But when you are going for and or like this, I mean, that is also going to do the same thing. That is also not supported. So basically, if you are going for logical ones, these are not supported. The bitwise ones, they are doing the logical job here. So probably Abhilash, you are asking the question like, what's the difference between this and this? One is the bitwise and other one is a kind of logical. Logicals are not directly supported, but bitwise are supported, and bitwise are doing the logical job here. In a sense, they are doing the logical and logical or based on what values you are having inside them. Okay, that's the difference between single or and double or simple pipe, single pipe and double pipes. Okay. Pranit, your question, when I create an np.array with the mixed values of values converted into same type str. Absolutely. So probably when you're talking about something like this, Pranit, if you can hold your question for a minute, I'll come back to that. Right now, we are talking about a kind of symmetric values, or we are talking about an array with all similar values. Okay, let's perform few operations on this. I'll come back and I'll show you some exceptional cases. Okay, so just hold your question. You definitely will get an answer. I'm talking about all positive cases right now. I'll talk about few negative cases. Negative in the sense, what will happen in that case when the things are not matching or when the things are not equal or something sort of that once we are done with all the operations. Okay. Okay, so now we understand like this is the function 3 where we are trying to get both the arrays kind of getting some operations done on each other. Something like a plus a2, a1 plus a2, a2, a1 minus a2, and so on and so forth. So probably now I understand that things are getting in a particular direction, and I can get all of these operations done very easily on these arrays. Okay, now I'll continue to perform few more operations. Let's say this is the next operation, or this is the next functionality that we should be aware about. When we say that all of these arrays are getting stored as a flat memory structure, I showed you that here, though it is a single dimension or though it is a multi-dimension, but still you see all of them are getting stored as a flat array, and no matter how many dimensions are there, all of them will get stored in one single flat array like this. Now if it is the case, let us see some properties of these arrays. Pay attention again. Import numpy, sorry, my bad, numpy as np. I'm going to start with, as usual, function 1. Right inside this, I'll create the same array, the one which I created earlier, a1, which is equals to np array. This is going to store 10, 20, 30, 40, 50, and 60, 6 values. I don't care about the memory. It's okay. It doesn't matter, but it's okay. So because I'm showing you the diagram where we have said the D type is equals to np.int 8, let's continue using it. Okay, so it's integer 8. That's it. First, let us understand what happens here. So probably I'm going to say that, why am I writing it? It's already there. I'm just going to reuse that code. It will save turn of my and your time. So these are all the properties we already have seen last time. Let me just print them one more time. Why? There's a reason. I'm going to show you a few things here, and I want you to pay attention here, because this is a little bit different and sometimes a bit difficult to digest for the first time. This is simple enough. I mean, you can understand that that's a single dimension array, which is kind of having one item, sorry, item size 1, data type integer 8, number of values 6, total memory will be 6 bytes, 1 into 6. Total value is again, total memory is 6, and number of dimensions 1, because we are having only one square bracket here, and there are 6 values inside one dimension, nothing different. Now, I showed you that though you are using a flat, or though you are using one dimension, or though you are using multi-dimension, but still the values are getting stored as a flat memory structure. So what can be done when I say the values can be stored as a flat memory structure? Watch what happens here. Because I know the A1 is going to get stored, though it is a single dimension, though it's a multi-dimension, though it is behind the scene getting stored like this. Now I can change the way to read the values from that array. Right now, because I said the n dimension is equals to 1, shape is equals to 6 comma, meaning there are 6 values in one dimension. But the same structure, I can kind of bend it by saying n dimension equals to 2 and shape is equals to 2 by 3. Oh, what do you mean by this? I'll show you here, see if you can understand. I'm going to say A2, but I'm now going to create a new one. I'll say that, hey, A1 dot reshape. A1 dot reshape means I'm going to say that, hey, you already have created a memory. Right now you are reading it as 0, 1, 2, 3, 4, 5. Now don't do it. Instead of that, read it like first three locations will be read as row 1, second 3 locations will be read as row 2. What do you mean by that? That means we are kind of reading it in a different fashion by saying the shape is equals to 2 by 3. Make sure that the values, or if you just multiply them, it should match with the total number of values you are having here. We are having 6 values. That's the reason why I took an example of 6 values there. So you can easily understand. If we can put all the 6 values in one single array like this, you can still read it 0, 1, 2, 3, 4, 5, or you can bend it, or you can just cut them down and put them next to each other like this. You can cut them down and put them next to each other. This becomes my 2-dimensional array. As simple as that. So basically, when I come back here and say, hey, just give me the information about this A2, you will surprised to see that the same A1, which was earlier 1-dimension array, will be read as 2-dimensional array now. Oh, don't you believe me? Just go back here and see yourself. This is A2.size. It's okay. Into A2.nByte will also give you the same one. A2.n dimensions and A2.shape. See what happens now. When I say run, the same array having the same values 10 to 60, but now while reading them, we are reading them as this is my first row, this is my second row, having 3 columns, in each of them. So I see the number of dimensions are 2 and the shape is kind of 2 by 3. Yes, Vipin, I think, yes, this is what you are looking for. And yes, this is what it can do behind the scene because it has a flat memory structure. It can make it read as 6 by 1, 1 by 6, 2 by 3, 3 by 2. All depends on you. Okay, let me show you one more example. Now I can maybe bend it in this way. Probably you can understand that. This is my first row, this is my second row, and this is my third row. Meaning I can bend it into 3 rows and 2 columns. How can I do it? Probably all we have to do here is like just change the shape. Just while reading the values, we can say, hey, don't read it like this way. Just read it like this way. Look at this. This is going to be my A3, sorry, A3. That's it. So when it is A3, probably you can understand again that this one is going to give you the values according to the rows and columns we have decided here. Let's see what is the memory requirement. How does it get created internally? How does it give me the value one by one? And see, if I go back and if I try to see the way the values are reading, you see that's a flat 1 dimension. That is 2 dimension where we are having 2 rows, 3 columns. It's 2 by 3, you can see here. And now I converted the same array into 2 by 3. So 3 by 2, 3 rows and 2 columns like this. So basically now I see the number of columns are 2, but now the shape is kind of 3 by 2. Guys, do you understand this? What we are doing here, we are trying to reshape it. We are not recreating the memory. We are simply saying, hey, just read it in a different way. That's it. That's it. That's a flat memory structure. That's an advantage you get here. Guess what? I can still do it in a little bit different fashion. I can create every single value as one row, having one column. In a sense, I can do something like this. This is my first row. This is my second row. This is my third row, and so on and so forth. So basically what I can do here is I can go back here and say A4 is equals to 6 rows, 1 column. I'm sorry, 1 row, 6 columns, like this. 1 row, 6 column means there'll be only 1 row and there'll be 6 columns inside it, and there'll be 6 rows and into 1 column like this. I can do it as per my requirement. So probably I can see 6 by 1. That's what I just mentioned here. So let's go back here and say 6 rows, 1 column in each. That's A4, A4, the one which I just showed you there. So A4, 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 and A4. That's it. So this is how we are kind of showing all the properties of this. And probably you will see this is still function 1, right? Yeah. Let me just go back here and read the values now. See, there are, I mean, this is the A4, which is having 1 row and 6 columns. Sorry, 6 rows and 1 column. There is nothing. I mean, you can just go back and try to read it like this. So this is how we are trying to read the values, and probably you can still convert that into the other way, 1 by 6. So however you want to read it, the main value, the main memory will stay same. So let's go back and say this is A5, and say this is A5, A5, and A5. That's why I was wondering, like, why the hell it didn't show it properly. Now I got it. So probably this is A5, this is A5, this is A5, this is A5, this is A5. That's where we are saying 1 row, 6 column. It's exactly similar to our original array. There's no such difference as such, but it's okay. It's just a second dimension we have added here. Look at the memory representation. Look at this. So this is a 6 by 1, 6 rows, 1, 2, 3, 4, 5, 6, having 1 column inside them, which means it's a 6 by 1. And this is 1 row having 6 columns inside it. This is the flat memory. There is only 1 dimension. There are 2 dimensions, 1 row, and 1 row is having 6 columns. Yes, exactly. It's a transposition of matrix. Absolutely. So what do you do here? You just try to change the locations and you will get your own representation of it. All I'm trying to say here is this. See, whenever you are kind of doing this job, probably you can understand however you want to read it, the memory representation will stay same. Either you can do it in this way, or maybe you can do it in this way, like this and this. Just put this aside. This and this. That's a one memory way. That's a one way to read the values. Or maybe you can just put it here and say do it 2 at a time. So 2 columns and 3 rows like this. Or maybe you can do it 1 at a time. Like this is my first one. This is my second one, and so on and so forth. That's my second one, and so on and so forth. So that is going to give me 6 rows, but having only 1 column inside each of them. You know, this is the way we can do it. So that's the 6 by 1. And finally, this is the 6th one. So this is the way we can, you know, arrange those values and we can get the things done. Very, very, very simple. That's the magic of having NumPy here, you know. So the NumPy is very famous doing all these operations on array. This is called as a reshape operation. Reshape means you are reading the existing memory in a little bit different fashion. It's like you are having a kind of a glass, or maybe half of the glass empty. Some might say that it's a half of the glass is empty. Some might say that half of glass is full. So that's how you are going to read it. I mean, depending again on your requirement, you can see the other half of it or maybe the first half of it. So that's the same thing we are doing here. So probably if I just want to label them, I can say that these are the different examples. We have just converted one single array into different representations. All of them are reading the same memory in the same fashion. You see, that's a memory. So that's how we can say it's 6 1 or it's only 6 comma, there is only one dimension in it, and that's the reason the second dimension is missing or empty. So this is 6 by 1. What about this one? This is a 6 by 1. I mean 6 by 1 in the sense there is a second dimension now. There is no second dimension. It's a 6 plain values. When you say this is a 3 by 2. So 3 by 2 means there are 3 rows, 2 columns. You see that here. And this is exactly opposite of it, 2 by 3. See, this is how we are kind of representing it. The same array, we just have kind of broken them into different representations or different reading schemes. So this is how the values will be read. This is how the things will be working. You know, that's it. Preeti, your question, do we have jagged arrays in NumPy? No, you can't. I mean, there is no jagged array here. Whenever you are having a jagged array, the only problem with this is like it takes a lot of memory and it becomes mutable. Both of them are not possible in NumPy. In NumPy, once the array is created, there is no way you can change the value. You can add something or you can delete something, because these are having a kind of a strict memory requirement. So you cannot have different columns in different rows. It's mandatory that number of columns should be exactly equal to exactly same in every single row. Okay, seems like Priti, you are coming from either Java or .NET, and in both the cases, or in JavaScript as well. So if you are coming from these languages, it is possible to do that there, but not possible in NumPy. Okay, Rajesh, your question, we are just changing the representation. Address will be contiguous. Yes, the address will be contiguous. The memory will be always contiguous. It's just the way we are reading the values in a different fashion. That's it. Okay, Rohit, second would be 1 by 6. One row with the second column. Second means what? The second, this one, this will be 6 1. That is 6 rows, 1 column. You're talking about this one. You're talking about this one. This is a 6. If I would have said this one, let's just give me a sec. If I would have said that, then it would be a kind of 2-dimensional locations, you know. So this you can consider it as a 2-dimension, means there is 1 and there is a 2, something like this. So maybe a value, a row within a row. Now you can consider this as a 1 by 6, something like this. So there is 1 row and 6 columns in it. I mean, right now there is only 1 row. You can have a second one as well. Vijay, what is a jagged array? Leave it. This is not supported in Python, so we don't have to talk about that. If I give you some information, again you will get confused. It's not supported by Python, so there is no reason to talk about it. Rohit, which one you are referring to? Maybe is it right now what you're saying here, or you still have any question? It's okay, fine, no problem. Okay, so probably when you talk about this here, probably when you talk about this here, you are kind of representing one single flat structure to different ways of reading the values. Still, in all the positions, in all the cases, the values will be stored in a flat memory structure. There is no change. It's going to be exactly same. It's just the way we are reading it. That's it. Okay. Okay. So probably now you understand like how the values are getting placed, how the array is getting created behind the scene, what different operations we can perform on that array. Now let's go to the next point. Next point is the one where we are going to talk about kind of this. Jenica, I'm purposefully not talking about this because many people are not coming from the other languages, so they don't know what you mean by a row having multiple columns. That's a reason. But anyways, it's okay. Even if you're putting it there, that's great. Not a big deal. Okay. Okay. So, I mean, I would love to talk about it, but again, it will unnecessarily increase the confusion. And because it's not supported by Python, that's the reason why I'm not talking about it. Anyways, we already have seen that in case of list case, by the way. I mean, in case of NumPy, it's not possible. In case of Python array, we already have seen it. All right. Exactly. So that's fine. Oh, by the way, yes, Jenica, if you're doing it there, then can you just print what happens there? Exactly. So you see those who are talking about this, just go ahead and np.array, just put what she has written there and try to create an array and see what happens. It's not supported because you will get an array, because every single row has to have the same number of columns. In normal list, it is possible, but not in case of NumPy array. Anyways, coming back here, let's go for the another example, a very quick example of it. Hopefully you can understand that. It's very simple, but let's cover it up. So someone was asking that question last time. Probably you can get that answer right here. See, now if I say that this is an array, array is immutable, and array is defined as collection of similar values, similar type values. This is what you generally call it as an array. So let me say array. Array means it is a contiguous memory location, contiguous memory location or contiguous memory allocation. This is the first property of an array, being an array. So that's the first one. Second one, it is nothing but the collection of similar values. So watch what happens now. Similar values or similar type values, whatever. That's called as an array. So probably when I say A1, and if I say something like np dot array, and if I say 10, 20, 30, 40, 50, 40 and 50, and if I print A1, which is equals to A1, and the type of it, you will see that this is an NP type array. So this is a type of A1, not important for me. The second one is important. So what is the data type of every single value inside it? So type of value in A1, which is equals to A1 dot D type. That is important. Okay. So watch what happens now. When I say run, probably you can see that in this case, this A1 is having a kind of all values stored as an integer 64. I mean, though you are having all of them are integers, behind the scene, it creates it as integer 64 values. Yes, absolutely right. Now, if I come back, watch what happens here. Now I'm going to come back here and say this is A2. I'll say 10.0. You can simply say 10 dot as well, doesn't matter. 0 is not required to mention. If you want, you can. It's not a big deal. I'll try to put this as a A2's type, and we'll try to print A2 as well. So when I say A2, you will see that here all of them are integer 64. Here all of them are float 64. Of course, there is float 32, float 16, float 8. That's it. Something like this. Now I'll come back here and try to do it with this condition and say, no, I want to go for str1, str2, and so on and so forth, you know. So let us see what does it do. This is A3, A3, and this is A3, and this is A3, A3. That's it. So let us run this code, and you will see that it's not directly shows you that it is a type of array, but it shows it is a type of string array, but it shows A3 is equals to less than U4. Now, what do you mean by U4 here? I don't know whether I mentioned this or not, but I can recall somewhere, I don't know when, but somewhere I must have said something like every character in Python string is a Unicode compliant. Yes, Unicode compliant. Exactly. So that U stands for Unicode here. It is telling me that every single value inside that array is a less than Unicode 4. Means there are less than 4 characters which are all Unicode compliant. That's what you can say here. Maybe if I try to change this 1, 2, 3, 1, 2, 3, 4, you can see that now the value will change. It will say U6 because it seems like the value's maximum number of characters or maybe the string having maximum number of characters are 6. So what is it doing behind the screen? Every single time it is allocating 12 bytes. One character will take 2 bytes. So if there are 6, there are 12 bytes for every single string, and that's how the locations will get allocated. Because we already have said that it has to be contiguous memory location, so it has to calculate the memory requirement first. So memory requirement for this will be maximum 6. Maybe the one which is having the maximum number of characters is 6. So it allocates a 6 bytes for every single string and it puts the characters there. So this is how the memory will be contiguously allocated. Now, this is little bit odd. Let's see if you can understand that. So this is going to be A4. What I'm going to do it, maybe I can do it in this way. This is A4 and let's say 10, maybe I'll say this one and I'll add one str as well. Doesn't matter, whatever value I'm going to go back. Now, as I said, array is nothing but collection of similar values, but you can understand here they are of different types. One of them is integer, the other one is the float, and the other one is a string. Now what can happen? I mean, what can be done here? Can we create float to integer, string to integer, integer to float, integer to string, or all of them to string? The answer is, when you are doing something like this, most of the time you will see that the values will get converted to a string, because every value can be converted to a string. Not every string can be converted to integer or float. So Python takes, or NumPy takes, a kind of a safer decision. It says I can easily convert 10 numeric to 10 string, 20.0 to numeric, I'm sorry, the string 20.0. So it converts every single thing into string, and then it says that, oh, it seems like u is 34. I mean, its maximum value it is allocating here is 32 bytes, and then it is going to do the job like this. So probably you can understand that when you are having heterogeneous values, by default everything gets converted to a string, and which is logical, because whenever you are looking at an array means it's a collection of similar values, and when I say it's a similar values, it has to allocate contiguous memory one after another. So it has to know how much memory is required to store every single value. If it doesn't calculate, or if it cannot calculate that, how can it allocate the memory? And that's the reason why it does that behind the scene. All of these values will get converted into string, and then a string, in this case 32 bytes, 32 bits will be 32 bytes will be allocated for every single item there, and all the values will get stored as a string. Guys, are you getting this? Someone was asking that question last time. I think you got the answer, right? It's okay, Adesh. But someone was asking that question. I don't know who asked that question, but I said you will get the answer later. Pranit, I think you asked that question. Exactly. So this is the answer to your question. This is important to understand, because when you are having an array in your mind, you always will think of collection of similar values. But if you are having a mixed values like this, you will see by default all of them will get converted to a string. Okay. Now one more, and then we'll call it a day. Maybe I'll go back to the last example quickly. This is my function 2, and I'm going to go back here and say this is an array. A1 is equals to, pay attention, it's a little bit simpler, but still A1 dot array, and in this case I'm going to go for maybe 10, 20, 30, 40, 50, 60, so on and so forth. 60, 70, I need some values, 70, 80, 90, and 100. That's it. So we have some values here. Probably I want to get some values by using the index position. So I want to go back and say, what is the value stored at the 0th location? You can easily get that by using something like A1 of 0, something like this. So it will tell me the A1 of 0 is equals to 10. You already have seen this last time in Python. You can say -1, you can get the -1, and -1 will be the almost last value. So in this case, -1 will be again 100. This is exactly same like what we have seen last time in Python. This is called as indexing. So we already have seen this in Python. Now, what is different in case of NumPy? Let's look at this here. Now, when you are looking for the values, I think it's better we can take a small example first, and I'll come back to this one. I need some large values, but for example, in this case, I want to go for passing all the values there. So I'll cut them down into, let's say 5, or let's say 3, or let's say 5, that's okay. So for example, pay attention. By the way, you already have seen this example of indexing and slicing. Can someone give me an example of slicing? I don't want to waste your and my time to do the same thing, because you already have done that, you know. So I would have said something like 0 to 3, and it would have given me the values from 0, 1, 2, exactly, something like this. We already have seen that earlier, you know. So I'm not talking about the slicing here, but I'm talking about something different. Pay attention. Now, sometimes, because when we talk about something like a slicing, let's run this code again quickly and see, we are getting the values from 0 to 3, like 0, 1, 2, 10, 20, 30, absolutely. But sometimes I don't want to go for I want to go for sequential values. I want to go in between values. Like I want to pick up the value 20, 40, and 50. You cannot solve this problem by using slicing behavior, because slicing will always go in sequence. So how do I go for it then? Look at this. If I want to print maybe the in between values, then see what is the value that we are looking for. Maybe 20. 20 is on 0, 1. So I'm looking for 1. So for now, I'll just try to print 1. Maybe This will print the value at first location, and that is 20. To be very precise, I want to go for 1, 2, no, I don't want to go for this, 3 and 4. So I want to go for 1, 3 and 4. These are the values I want to go for, you know. So if you want to put them here, you can put them in one single list. Though it feels like you are adding a list within a list, this is not exactly what you think of. Maybe I can say index positions. I'll consider this as an array, and this array will be passed here as the values which you are looking for. So probably I can say that this is a kind of, you know, a number of positions I'm looking for, in between positions I'm looking for. So when I say run, you will see that I'm getting 20, 40 and 50. Look at this, 20, 40 and 50, not 30 in between. If I say 1 and 4, you see it's going to give me the value directly at 1 and 4, like this, 20 and 50. Guys, do you understand what am I doing here? Let's use this example, 20 and 40. Guys, can you understand what I'm taking, what I'm showing you here? You may put this here, or you may put this like this. It's not required to create a separate list like this. You can directly put it like this. So I didn't want you to get a little bit confused by looking at two square brackets. That's the reason I separated it out. But you know that you can simply put it here in place of that variable, and you still can achieve the same thing. So basically, this is going to give you an answer of 20 and 50, first and fourth position, both of them. This one can be written again in a different representation. See, this can be written by saying, hey, I don't need this position. I do need this position. I don't need this, don't need this, I do need this. Whatever positions you are looking for, instead of going for 1 and 4, you can say, I don't need this, false. I need this, true. I don't need this, I don't need this, I need this. I'm talking about all the positions, position 0, position 1, position 2, position 3, position 4. So I'm looking for position 1. I'm saying that on position 1 is true. I'm looking for position 4. On position 4, I'm saying true. The answer is exactly same. There is no change. You see, I'm still getting as 20 and 50, something like this. Probably you can understand that whenever you are getting a kind of true, false, true, false, true, false like this, depending on which position you are saying true, you are going to get the value at that position. So for getting 2050, you are having a couple of different options, and all of them are listed here. Now, why was I showing this example here? Because of this. Now, this is maybe you can say cherry on a cake. This is the way generally we are going to deal with NumPy when we are using it in a real life. Imagine that we are having the values starting from 10 to 100. First, answer this question. If I say A1 greater than 30, or let's say A1 greater than 40, what will I get here? Can someone please quickly tell me what will I get here if I say A1 greater than 40? What do you mean by that? Exactly. You will get a value starting from 50 to 100, not the 50 to 100, but you are going to get the values false, 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 true, 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 like this. So if I run this, what will you get? You will get a new array where every position will be checked and say, hey, this is false, this is false, this is false, false, because all of them are not greater than 40. But starting from here, I'll get all the values as 40. Guess what? Last time I used an array of true, false, true, false, true, false. This time I got an array of true, false, true, false, true, false. That simply means I can go back here, can just get this one and say print A1 of true, false, true, false, true, false. The only difference is here we have to put the comma, because while printing it, it doesn't put one. Not a big deal. I can do it quickly, like this one here, this one here, this one here, this one here, and this one here. Wherever you are saying true, you are going to get the values at that position. You see, 50 to 60. Haha, what do you mean by that? What do you mean by that here is, whatever I just did here, I printed the answer of this and then I put that answer here. Why can't you say A1 of? How did you get this? I got it by saying A1 of 40. Little bit different, but yeah, this can be done. In Python, we have seen something called as indexing. In Python, we have seen something called as a slicing. In NumPy, this is called as a filtering. Someone was asking that question earlier as well. I said, just hold your question. When we'll go to NumPy, we'll see this answer. Look, I'm getting the values directly by saying A1 greater than 40. More importantly, you need to understand A1 greater than 40 will return an array, which is going to have true, false like this. And those true, false, we are passing them to this A1, and based on the position where we are saying true, you are going to get the value at that position. So this is a combination of what we have seen in previous two examples. Okay, a quick question. How do I get all the values below 60? How do I do that? Don't you see how simple is that now? A1 of A1 less than 60. That's it. Exactly. So just go back here and you will get all the values less than 50, less than 60. Imagine that you are having people maybe with these salaries. Let's say this is the quickest example. Salary, one is getting, let's say 10K, 15K, another one is 7K, another one is 8K, next one is 20K, third one is 50K, fourth one is maybe something like this. I want to fire a few people. Those who are getting the salary above 50, I can't afford them now because of the COVID and because of the pandemic. I want to fire them. How do I fire them? I need to find them first. How do I find them? Not a big deal. You are in NumPy. You can just use one single query and say, hey, salary is greater than 50, greater than or equals to 50. That's it. Or maybe greater than 20. Whoever is greater than 20, you see how simple is that? I got the answer. Salary is greater than 20. Sorry, my bad. It should be np.array. This is not possible on list. This is possible only on NumPy array. And you see, I got two people who are getting salary greater than 20. These people, I need to fire them. How simple is that? I mean, right now I'm dealing with a simple value like integer. Instead of that, you can put a dictionary and you can still do the same job with a little bit modification. We don't generally deal with the dictionaries when you are in NumPy. In NumPy, we deal with only flat array. That's the reason why NumPy is considered as the base for many different packages, the ones we are going to see in the next few sessions. Guys, are you okay? Falling in love with Python. I already fell in love with Python. I think you started falling in love in Python now. Vipin, that's good. That's good because this is just the beginning. When you go to Pandas, you will see even better examples than this. In Pandas, when you learn the Pandas, you don't need Python, you don't need to even learn SQL at all, because all the SQL can do, you can do it in Pandas, writing Python simple syntax. I'll prove that fact on Monday. On Monday, we are going to look at the Pandas. Will be little bit advanced to start with, but it's okay. It will be based on NumPy. So if you can practice the NumPy tomorrow and after tomorrow, hopefully Pandas will be pretty much easier for you. Anyways, NumPy is based for SciPy. There are many others, Pandas, Matplotlib, few which we are going to use in the next couple of sessions. Okay. One more request to all of you. I know many people already have dropped off, but you are having 2 days with you. So probably please install MySQL on your machine. I mean, I don't want to leave that topic in between. I mean, I want you to, if you are interested again, I want you to, deal with your databases as well. And if I want you to talk to the database, you have to have database like MySQL running on your machine. I'm going to show you an example of how you can connect your Python application to MySQL and persist the data or perform all the MySQL queries there. That will be the easiest way to persist the data. Provided, one, you know MySQL, you know queries. If you don't know queries, you can simply skip that session, not a big deal. Or if you are really enthusiastic about that, you have 2 days. I'm telling you right now, not only 2 days, you are having, let's say, next 4 or 5 days. So when you are having this much of time, you can easily go and do some practice on your own. I'm talking about the MySQL practice, not Python, but MySQL. I'll tell you how to connect your Python application to MySQL. Okay, so it's exactly like SQL. Install MySQL, go on Google and see how it can be installed. What are the basic things that you need to know? And once you know them, probably you can just install it and go with it. It's free. It's not at all going to cost you a single penny. Just go download MySQL. It's a database. You should be aware about what database is, the tables and the collections and all that stuff. Those who are interested, I'm going to show you that demo anyways. Maybe it will be an extra session than what we are seeing here, but I want that to again they're included in the kind of this package when we talk about the Python. Okay. Okay, one more. If you don't have any idea, don't worry. Just spend some time. It's way easy. It's way easy. Okay. Anyways, I'm telling you something more than that. Importantly, today is Friday. It was supposedly day before, 2 days before yesterday. 21st was our final day. I mean, that was considered earlier, but as I said, it will take more time. So we have increased it to the next week. So probably the next week, Friday, will be our last day. I think not Friday, it will be Saturday if required, but Friday or Saturday will be our last day. Okay. I'm telling you what we are going to see in the next week. We are going to talk about pandas. We are going to talk about matplotlib and Seaborn's simple example, not very advanced, but couple of examples. Then OpenCV, very quick example of it again. Then something like SQL connection. That's what we are going to plan here. And finally, there is one more I forgot. Maybe Flask. That's what we are going to see. Okay. 5 packages, 5 days. If required, we'll go for the 6 day, but I don't think 6 day will be required. But anyways, I'm just telling you beforehand. So when you are having maybe a couple of days in between, just practice it very well. So it will be easy way to go for. Web scraping, Selenium, that's one more thing. Yes, Priyanka, 6th day will be required. I know for sure. No worries. So probably just practice this and probably you will see all the packages and it will be worth of using the Python there. Anyways, I think it's better we can call it a day. So probably we can continue on next Monday with the next package, and the next package will be pandas. Okay, get it installed. You know how to install now. npm 3 pip3 install pandas. That's it, as simple as that. Anyways, guys, thank you again for attending today's session. Hopefully I'll see you tomorrow, not tomorrow, on Monday exactly at 8 o'clock. Till then, have a very great day ahead. Have a very good weekend. Enjoy it. And probably on Monday, feel fresh with new topics. Okay. Thank you. Thank you one more time. Bye-bye.